Hey everybody, this is Larry. This is day 22 of the Leetcode December Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem, another linked list poem, it seems like, just from looking at it. This is going to be my last Leetcode daily video for the year in America. So I'm going to do it in whatever country I'll be in tomorrow. Check in or join the Discord to kind of figure that out a little bit. Also, maybe I'll spam a little bit. You can always check on my Instagram to see where I'm up to. I don't know. It's not. I don't make money on any of this, so I don't know. I just feel like sharing. Okay, so today's poem is reorder list. So what I want for the holidays is for you to hit the like button and the subscribe button and join me on Discord and all that stuff. Anyway, okay, so you have a linked list and you can reorder them to. Okay, almost like I was gonna say perfect shuffle, but I guess it's not a perfect shuffle. It's just like like a first, last, and then recursively, right? And then, so that's so that's a little bit. I mean, you have to be deliberate about what you do. I think this is not that bad, per se. It's just a little bit tricky. If you try to do, I guess my first instinct, to be honest, is just, just some sort of recursive-y thing. But as a result, then recursion, of course, is just a replacement sometimes. I mean, maybe a harder replacement other times for an explicit stack, right? And we're gonna have a stack. Then it's a little bit awkward because then like you're almost like. Just like putting it in different things, but of course also with that's gonna be linear space if you use a stack. So I'm trying to think whether I can do this in all of one space. I would imagine no, and the reason is because there are no backward pointers, right? And if you have backward pointers, I think this is a trivial thing to do in all of one space, even though it might be annoying anyway. But without that, I think using a stack is probably the closest. And there are other ways you could do it. You could construct a back pointing space almost implicitly with a stack as well. So there are kind of things depending on how explicit you want to make it. But either way, it seems like the case is going to be linear time or linear space. Linear time is the lower bound anyway. Can I do this in? Yeah, I don't know if I can do this in a better way, to be honest, in terms of space, because there's no way to walk backwards, right? And I mean, at least not. Yeah, so I think I'm gonna try doing that, and then we'll see what happens. We can maybe learn from it to see if there is an all one space one. I don't know if I could prove the lower bound on this one. So yeah, at least for space. Okay, so the first thing I would like to do is I just have a new head. That points to an actual head. This way we can kind of muck around a little bit in an easy way. This is done next. Whoops. Okay. And then now, I mean, if we're going to, the awkward thing, to be honest, is that if we're going to use a stack, you almost kind of want the beginning and the end at the same time. I mean, because the way that you would use this, if you only can use a stack, you just keep on popping until like, I don't know, like the beginning catches up to the end kind of thing. But in that case, you might as well use a deck, right? And of course, if you use a deck, you might as well also put it in an array. But that feels like too much cheating. So I don't know. Is that, what do you think, everybody at home? Is that like too, whatever? Anyway, I am solving this live, so please feel free to fast forward or skip ahead, and maybe we'll learn something together. But I am gonna, I mean, I don't know, it just feels very weird to kind of cheat on something that I want to learn, but I also don't know if there's a all of one bound one. I mean, maybe you could do it, like I said, maybe you could do it recursively in a cleaner way, but that's still gonna be O of n space, because you're just implicitly popping off the recursion, right? So yeah, so I'm gonna end up using I want to say a deck for this one, and then just construct it one by one. So let's do that. Okay, yeah. And then if I'm really wrong, then we'll both learn something together. So yeah, so let's just say Q is And then now we just go through the list, right? Current is equal to head, while current is not none, q dot append current. And then of course current is equal to current dot next. Okay, now we just do what we said we would do, right? So which is while length of q is greater than 0, we pop off the front and then pop off the head. And then maybe here, maybe I didn't need this quite yet. No, I mean that's fine. So then now we just said current is equal to new head. Yeah, maybe we didn't need this. I usually do it just because it's a good sentinel, but I guess in this case it's not really necessary. Okay, so then now first we pop off the front, so next is equal to q dot pop left, right? And then now, well, next is current is equal to current dot net. No, do we? No. Oh yeah. Then current is equal to current dot next, which is now the new head, and then now we pop one off the end, right? Is equal to q dot pop, just regular pop, if I could spell it, and then current dot next, and that's pretty much it. Of course, we have to add a thing here so that we verify, and then at the very end, current dot next is equal to none, and then we just return new head dot next. I think this should be right, but it still feels very cheating-y. But let's make sure if we're going to cheat, at least make sure our cheating is correct, right? Because that would be sad if you cheat and still get it wrong. I want to do two things. One is just have a bigger example, and then two is just having smaller examples. I don't know if 0 node is possible. Nope, at least 1 node, so okay. I mean, and this is clearly linear time, so if it works, I don't really worry about time limit exceeded. Though, if you recall from my contest video from 3 days ago, I thought that as well, but I had a typo, so yikes. So you should test it, but it is annoying to test in this thing. One thing you can do if you really want to test is just automatically generate this thing where, for example, you could do something like I don't know, was it 5 times 10 to the 4th? Oops. Something like that, and then you could do, I don't know, like current is equal to head, and then current dot next is equal to list node, or maybe just list node, and then or actually maybe just, yeah, okay, head is equal to current, and then we the other way. And then current dot next is equal to this node, current dot wow is equal to I, make this I, and then current is equal to current dot next. And then now here, of course, now head will point to a node that has a linked list that's so many rows. And of course when you run it, you of course get the wrong That's weird, actually. Huh. What I was going to say is that in theory you should have a long node, so then all these would be wrong answers, but they'll be wrong in a different way. Why is this wrong like this though? Is head that's weird. What I would maybe I'll do it the other way. Right? Head is current is equal to head. Current dot row is equal to -1. It doesn't. I guess 1 doesn't really matter. Huh. Why am I outputting so few elements? That's and also the wrong answer. I guess that's a little bit awkward. Did I mess something up? Let's see. I guess this is wrong, but conceptually something like that is what I would do. And judging by this this time limit exceeders because we're printing too much, to be honest. But I don't know why our output is wrong. but in a weird way. Because I do think I am constructing a node. Oh, whoops. No, I mean, this is fine. I guess I'll do something like this instead, but this is very awkward now. We have to remove it because now we're going to get another time limit exceeded because we're printing way too much, right? But, But in theory, okay, I don't know what's going on here today, but in theory, you should, or what I was expecting, which is why this is awkward, is that we will print out an answer that's 10 to the 5th long, something like that, 10 to the 4th, 5 times 10 to the 4th, because that is now the input to this thing. But then I don't know why this is so weird, because this thing is isolated from here, so I don't know. I mean, that's maybe what I get for reusing variable names. So I guess we'll do head is equal to a fake head. Oops. Yeah, fake head. And then here, and maybe we put it in a constructor. Let's just say create x, and then we do something like this. So I don't know. This is a little bit off by 1, maybe even, but I don't know why this happens. So then you could do head is equal to create of, like, you know, let's just say 10, and then see if this. Oh well, this is wrong, but that is very weird. Maybe I overwrite some context by accident. How is this the case? Honestly, I'm honestly really confused. Yeah, okay. I think, to be honest, I think what we're doing is right. But maybe there's something weird with the checker. Because as you can see, before we run our loop, we do have a node from 1 to 10, which is what we expect. And then here as well. Of course, in real life, you just write actual test. And then here, yeah, the end current is none. That's fine. And then now we just return, or let's print new head. Let's see. Oh, because there's a cycle? Is that it? Oh, because we don't do this thing. Okay, let's see. This should be good. Because current dot next to it. Yeah, okay. So I guess there's some weird thing with the formatter, right? Or with the output that is just really weird. I don't get it. This isn't even like consistent with what I'm outputting. Like, it's not even the numbers in the right order. I think they're, am I like, I don't think I'm being that weird about it, right? It's just that, okay. So I think Leetcode has some like formatting thing with this one, for especially for linked lists. And it's kind of fun to kind of experience what's going on, because as you can see, if we print out new head.next, we have what we expect, the wrong answer, but the answer we expect, because we have a node of 10 rows, right? And of course, it just returns a node of 10 rows. But then output, I don't know why they have this output. It is very weird. And output is like not even the same. It's just 1, 2, 3, 4. Like, this is just the same as the input. It's not even the output. Oh, I see. Okay, I see. Actually, no. I was way wrong. It's because this is not a return thing. It is modify head in place. So therefore, it was checking the wrong thing for me to construct this test. What we need actually is... I don't know, maybe, okay, so we don't do this, but maybe you could do something like new head.next. So you, okay, so they make it so that you don't, because we have to modify head directly, right? Okay, I guess that makes sense. Okay, now I see it. It's not a, weird thing that Leetcode is doing. It's just that we have to modify head in place. That makes it a little bit trickier to kind of do our weird testing. But in any case, this is correct for what we said. So let's just ignore this for now. But in theory, if you want to test a long case in Leetcode, that's how we'd do it, at least for another problem, because then you would be able to construct a longer case here. In place stuff is a little bit weird. I mean, I could still do it, but for now, you know, I mean, because we'll just modify this in place to have those, you know, create a lot of nodes after that or something. But for now, we'll just ignore it. So let's give it a submit. I got a one-time error. Hopefully I don't get one this time. Yes. Yeah. This is going to be linear time, linear space. Let's see what I did last time. Do I have a constant space solution? No, I do this. Ooh. Oh, I did have a constant space solution. Oh, does this work? I mean, this is Freud's solution. So you go to the middle, and then Let's see. Well, this time today I have completely failure. I hope you're having fun with this one, but I am. Let's see. How does the middle one work? I really don't like these kind of algorithms, to be honest. It doesn't really come up in competitive or interviews. I mean, it used to a lot more, but a lot less now. Though this one, I feel a little bit sad that I didn't think about this. But okay, so you have the head in the middle, and then what does the middle one point to, right? Well, the middle one is going to be last. Oh, one of the middle ones will be last, and then the second one will be. Yeah, and this is the awkward. Okay, so now that you have it pointed to the middle, you slowly, as you go to the left, go to the right on the middle. Okay, I mean, wow, this is hard. How did I do it in the one-time error one? Whoops. Well, past Larry is a little bit smarter today, so definitely check out that video. I think the idea here, and this is one of those things where I always say about linked lists, which is that to debug or even to think of ideas, just draw it out. Just have pointers, and then, you know, see which one goes as you go. This one is a very famous turtle and hare type thing, tortoise and hare, or Freud's thing where you have a fast pointer and a slow pointer. You use that to find the middle, and then now once you have the middle, I guess you just kind of keep track of a lot of stuff. But I don't know how this works. Did I misread this one? No, because I wrote Discord and it worked okay. How do you get the end to the... Okay, so now we have both the middle, okay, the head and the middle, and then we look at the next pointers, and then the head's next is equal to middle current. How does this work? Not gonna lie, I don't quite know how this works. I mean, this works for a perfect shuffle, unless I'm really misunderstanding this problem. Basically, you're taking the middle and put it as the next item. But I don't see how that gets the last item. How does this work? Let me take a quick look. And sometimes visualization is a lot of different things. Wow, that does work. Did I misunderstand this problem? Maybe I misunderstood this problem. Today is a different kind of video. I hope you're enjoying it at home. I am very confused. Okay, so we get the middle. Yeah, okay, with the middle. The head. But we're taking the middle and then set it to head next. Why does that wrong? I mean, why is that right? And then we put it in. We take the middle. Oh, I see what we're doing. I was kind of skimmed over this part, but this is so silly. But okay, fine. Okay, fine. Huh. I guess I didn't think about this one. So, I mean, I'll go with the solution, though obviously I have this thing. And this is why sometimes we review our Go code, is because the past Larry might be smarter than the current Larry. But basically the idea is that, okay, you find the middle in by this turtles and hare algorithm, which is that you have 2 pointers, one fast pointer and one slower pointer. And then after you get the middle pointer, you reverse the second list. So you start from the middle and then you reverse so that it points the other way. And then now this is actually the end of the list. So okay, let me draw this out just to kind of for visualization. Hang on. I mean, I'm not going to explain this code, though I will show you. Or I'm explaining this code, but I'm not going to do it like a step-by-step thing. I'll just kind of draw it out for y'all. Basically, you have these pointers. This is a hard problem. At least I didn't get it, so yikes. So basically, you have something like this, right? Drawing with a mouse, excuse me, and then you know, it's something like that, right? And then the idea is that, you know, now you have this. You find the middle pointer just by the turtles and Hoy's algorithm, turtles and hare algorithm. Right? Let's just say this is the middle. I don't know how I handled off by one, but then now here you reverse this list starting from here. So then maybe this will. I don't know if this is quite right what my code is doing because of off by ones. But for example, it would you know, continue. Let's just say this one, it would be the same. Except for on the right side, we would have something like this, maybe. Now pointing here, and as we're going from left to right, going here, we keep track of the last pointer, right? So that we can kind of, you know, and you can look at the code to kind of see what I'm doing here. I just keep track of the previous pointer, and I keep on doing that to reverse it, right? And then once I reverse it, now we can do the idea of the perfect shuffle, right? And then so then now we start from here, we go okay here, and then we point to this one, and then this one we point to this one, and then this one we point to this one, and so forth, right? So that's basically the idea. It's yeah, I mean, I'm gonna hide this. I mean, yeah, I hope that visualization is enough, but that's basically what I have here. And that's pretty much it. Wow, that is a very good O of 1 solution. O of n time, O of 1 extra space. Yeah, I mean, I don't know what else to say about this one. I did not get it, so if you did not get it as well, give me a like button, give me a like, and let me know in the comments, and we'll feel a little sad together. But this is actually very clever, and today I am not clever enough. So yikes. Anyway, I guess that's a way to end off America in 2021. Dubious and with a cheating answer. But anyway, thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord. But be sure to stay good, stay healthy, to good mental health. I'll see you later. Bye-bye.